In this video, I'm going to go over how to do the questions for Quiz B from Chapter 5. You guys are going to have a few Delta Math links to do from Chapter 5 that talks about kind of looking at the potential for outliers as well as some box plots. And then I also have a few Google Form exit tickets that I've used in the past where the questions will be very similar to the ones that we'll do in number 2, and you'll get to get immediate feedback on those after you click submit. All right, so let's try the first one here. We've got a 5-number summary for the temperatures of students on a particular day for the students that have gone to the nurse. All right, so it says, question A, would you expect the mean temperature, so the average temperature, which they don't give us, of all the students who visited the nurse's office to be higher or lower than the median? And this is a little tricky to do by just kind of like looking at the numbers, especially because they're all so close. So kind of the math that I would do here is I would find the distance from the max minus the median, and then find the median minus the minus the minimum, and compare how far away our highest and lowest numbers are from the center. All right, so in this case, I'm going to do 101.8 degrees minus 98.25 degrees, and then the same idea, but just find the distance from the median to the lowest number, the minimum. Okay, and so this will give me an idea of which one is closer or which one is farther away, however you want to look at it. So the first one is about 3.5 degrees away. The maximum is 3.5 degrees higher than the median. And in terms of the distance to the minimum, it's 1.65, so just over 1.5 degrees. So from my understanding of the average, right, the mean, is that the mean is going to be pulled, right, in the direction of potential outliers. Again, I haven't calculated what we call our fences yet to determine specifically if I have any outliers in this data. But I'm curious to see if the min or the max could be an outlier, and the fact that the maximum is 3.5 degrees higher compared to the median, as opposed to the minimum only being a little over 1.5 degrees farther away. I think that the maximum, so I would say, I think the maximum is going to pull the mean towards it. So I think the max will pull the mean towards it. So because of that, I'm going to say I think the mean is going to be higher than the median. So therefore, mean will be greater than median. All right, let's do letter B. So this is our first opportunity together to actually calculate outliers. All right, so I'm going to go through the process of how to do this. All right, so step number 1 is to find the IQR. All right, so when I look in my 5-number summary, I'm going to subtract quartile 3, so 98.6 degrees, minus quartile 1, 97.85 degrees. So let's get that IQR. That's always the first step. All right, that gives me 0.75 degrees. Okay, now once you find the IQR, step 2 is to take your IQR and multiply it by 1.5. All right, that's the number that we're going to use in our class. You might take stats in college, and your professor might ask you to use the number 2 times the IQR. But for our purposes, we're going to do 1.5 times our IQR. So we get 1.125 degrees. Okay, so this number, which is, there's not really a name for it besides it's 1.5 times the IQR. What you're going to do is you're going to use that number to create what we call the fences. So I have what I call a lower fence and an upper fence. All right, so the lower fence is going to be quartile 1 minus that number, so 1.125, and the upper fence is quartile 3 plus that 1.5 times the IQR number, okay? So in this case, I'm going to have 97.85 minus 1.125.
to get 96.725 degrees. And my upper fence is going to be 98.6 plus 1.125 to get 99.725 degrees. Okay, so the way I always view this, and this is kind of, I'm sure I'll reference this in classes. When I look outside into my backyard where it's fenced off, if I look to the left and I go outside my fence, and I live on like the end of the streets, the corner lot. So outside my fence is like where the mailbox is. And then to the right, so outside the right side of my fence is my neighbor's yard. If it's in my yard, all right, so if the data value is in my yard, it is not an outlier. But if I look out there, right, like whenever Henry or anyone, usually it's Henry now because he's the oldest, but he hits a golf ball or if he hits a baseball over the fence, out over into the street or towards the mailboxes, right, he has now hit a ball that is considered an outlier. It's outside of my fence. So I view these as kind of like, if it's outside, so to the left of the lower fence, it's going to be an outlier. And if it's above or to the right of the upper fence, it's an outlier. So before I even answer this question B, right, if I look at my minimum, right, my minimum of 96.6 is lower than 96.725. So that minimum is an outlier. Same with my maximum. It is above the upper fence. Now, even if we don't answer letter B, if you said that there were two outliers in this data, you wouldn't be correct because there could be students that have like 96.65 degrees, so just above that lowest student, but still an outlier. And there could be a student on the other side that's still running a fever of like 100 degrees, but they just aren't the max. That would still be an outlier. Right? You're still greater than the upper fence. So just keep in mind, like they'll try to mess you up on the AP exam. There's not only two, there's just right now at least two outliers. Okay, so let's do letter B, where we're analyzing these three numbers. All right, so 96.7 is below my 96.725. All right, so that is going to be an outlier. So I guess I'll write it. Don't have much room here. I'll just say, let's do it over here. 96.7 degrees is an outlier, right? It's below my lower fence. 98.4 is in between those fences, so not an outlier. And 99.2 degrees is also below that upper fence, so not an outlier. So the only outlier was that 96.7 degree student, just barely, right? Just barely by less than that of a degree. Okay, let's do number 2. So we are given 4 box plots, and hopefully by now, if you've done some of the Delta Mathlinks, if you've read the book about box plots, if you've watched the video, or I think in class what I'm going to do is do the example with the made-up McTofu and Moose Burgers restaurants, just because it's so good to kind of see what those box plots look like in person one time at least. Right, you should kind of know the breakdown here. I'll just use the easiest one because there are no outliers, and you can kind of see both whiskers is the pedestrian. So if I just go ahead and outline in red this box, right? The lower end of the box is quartile 1. Wherever that line in the middle, I'm going to say in the middle of the box, as you can see, it's not always in the middle of the box, is the median. The upper end of the box, and these are vertical box plots, but horizontal are exactly the same. So the one that's the greatest will be the quartile 3. And then because these don't have any outliers, that is your maximum, and this is your minimum. Okay, so if you look at the two that are to the left of it, driver and passenger, you'll notice those little circles. Those open circles are outliers. So I'll just show you, since driver only has one outlier. So this number here, so 90, gosh, that's an old person driving, 95, let's say. That person is the highest data value inside the upper fence. All right, so this open circle here of that person who's maybe like 99 years old driving, incredible, by the way. That person is the maximum, but they are an outlier, so they're outside the fence. So I just want to make sure you understand that that's still a data value, right? Like same thing with this passenger. You still have a passenger who's almost 100 years old. That's just one of many outliers that are past the upper fence. All right, so just keep that in mind when you're doing outliers. Okay, let's answer some questions. It says, which role involved the youngest person and what is the age? So really the lowest number here I see down here is passenger. All right, so passenger, which kind of makes sense, right? Involved in an accident. All right, it looks like it's really close to 0, so I'm assuming this is someone who's an infant, right? Hopefully they're in an infant car seat that's not expired, facing rear and buckled correctly. Which role had the lowest median age? So as I mentioned, the line that's in the middle of the box, you can't see me doing it, I'm doing air quotes on middle, right? So the line that's in the box, that's the median. So I can highlight those for you if you would like for all of them. So this one, this one, this one, and I already pointed out that one. All right, so it's really close, but it looks like passenger again is going to win this one, just barely. It's very close. All right, but passenger is just shy of cyclist, and I'm going to say that that's 21 years old. Again, if you put 20, 22, that's fine. I'm not that worried about it. Which role had the smallest range of ages and what is it? So this is where I usually see the first kind of mistake happen. Remember, since it says range and doesn't say IQR, range is the highest minus the lowest. So even if you've got outliers, you got to factor those in. So when I look at the range for like driver and passenger, I have to use these ones I already put arrows with, these people that are almost 99 years old or almost 100, right? I've got to do 100 minus, about 15, so 85-year range, and then almost 100 minus 0. I mean, that's almost 100-year range for the passenger, so it's not going to be those. All right, and then so if you look at cyclist and pedestrian, those box plots, you can see that the edges of these whiskers, right, compared to cyclist and pedestrian, the cyclist is going to be a much smaller range, all right, because they don't have any outliers. So I'm going to say cyclist, and I'm going to estimate it at 52 and 11, so I guess I'll just say 41 years. Again, this is approximate guesses. Okay, which role had the largest IQR? So when you look at IQR, since I kind of used pedestrian to show you the different components here, the width of the box is your IQR. So when it says the largest IQR, I'm looking for whichever one has the longest or the widest box. So in this case, I see passenger has the narrowest or smallest box. All right, so that I know is not going to be my answer. That's the smallest one. So the largest box is actually the one that I mentioned earlier, which is pedestrian. All right, so that's going to be the largest IQR. And estimating 65 and 20. Sure, that's not right, but I'll just say approximately 45 years. Okay, so the last question before we finish this video. Which role generally involves the oldest people? And this can be tough to kind of understand as you're starting to learn what a box plot is. But what most students end up doing incorrectly here is they get drawn to driver and passenger because they have the highest data values, and passenger has a lot of outliers up there, and driver just has a lot of people that are older in that upper tail, or I should say upper whisker. But really, the key thing I look at here is, and I'll highlight it for you, I noticed that the median right here for pedestrian is around 45. And so if I highlight, north of that 45 all the way up to the maximum for pedestrian is about high 80s maybe, right? You guys know that the median splits the data in half. So we're saying that half, all right, so half of the pedestrians involved in these accidents are over the age of 45. And when you look at driver and passenger, that's not even close, right? For driver, your half is like all the way down to 35, and then passenger, the median is always all the way down into the low 20s. So even though pedestrian doesn't have any outliers or doesn't even have the maximum, right? It doesn't have anyone that's over 90. The fact that it has over half of its data values are above 45 years old means generally that involves the oldest people, which kind of makes sense when we think about it in terms of all the rules that were given here. So I'm going to say pedestrian because 50% of the values are over 45, I could have said people, sorry, not values, years old. All right. So that's just something that you kind of have to get used to in working with box plots. Okay, so don't forget, if you feel ready to try the exit tickets, there's 2 of them to try for using, doing questions like number 2, and then also a few Delta Math links. Good luck.